Good morning, everyone, and welcome to today's Faculty Friday. My name is Patrick Carr. Jordan is away today, so I'll be your host through today's Faculty Friday. And welcome back to the Lakehead Live series. Today, we are going to be talking to Dr. Craig MacKinnon from the Faculty of Chemistry. But before we get into it, I just want to talk a little bit more about the Lakehead Live events. So as many of you know, Lakehead Live has been going live every weekday for the better part of 2 months. Previously this week, we had a Monday meetup with the Student Success Center, International Student Services rather, and we talked about academic integrity. We go live every day at 10 a.m. to talk about different things. On Tuesday, on Transition Tuesday, we had Jen, our immigration advisor here at Lakehead, talk about study permits and immigration. Of course, we're continuing our Wednesday weekly, where you get to talk to not only myself, but other Lakehead representatives about admissions questions at the undergraduate and graduate level. On Thursdays, we had our Transition Thursday hosted by our immigration advisor, and we talked about this week how to be a successful online learner. And then obviously today is Faculty Friday, and next week on Monday, our International Student Services team will be having a graduate student chat. So if you're a graduate student, I would recommend you tune into this event. They're going to talk about grad student regulations, the process of being a grad student, what it's like to be a grad student. They'll have representatives from the Faculty of Graduate Studies as well as current graduate level students. As I mentioned, the Lakehead Live series goes live every day, daily at 10 a.m. Eastern Daylight Time, which is Thunder Bay and Aurelia time. And we're here to answer your questions, as well as present to you different information, and it's a collaborative venture between not only the International Enrollment Department as well as our International Student Services team. As I said, my name is Patrick Carr. I am one of the international recruitment officers here at Lakehead University. I primarily work with students out of the Middle East, Africa, as well as the Caribbean. And I'm here to answer any questions today and host this webinar, but I'm joined by a very special guest. Dr. Craig MacKinnon. He is the chair and a faculty professor in the chemistry program. And I will get Dr. MacKinnon to introduce himself.
Hello, everybody. I actually can't see my own video right now, so hopefully I'm sort of in the frame.
You're actually dead center. You're perfect.
All right. Now I just have to not move. So my name is Craig MacKinnon, and as Patrick said, I am the chair of the Department of Chemistry. I'm also a faculty member, and perhaps maybe even most importantly, for those of you who are joining us today, I am the instructor for first year chemistry. So if you come to Lakehead in the fall, then you will be sitting virtually, I guess, in my classroom. And maybe we'll talk a little bit about that a little bit later as we go along.
Awesome. Yeah, so in today's webinar, we're going to cover a brief program overview of the chemistry program. We're going to focus in on some areas of study. We're going to talk about first year course selection. As always, we're going to talk about the experiential learning opportunities, the hands-on learning opportunities and research opportunities in the faculty. And we're going to talk a little bit about some of the possible career outcomes that students have achieved. So we have lots to talk about today. As always, if you like what you see, just remember that we'll be putting this up on our YouTube video in a few days, and we have an excellent back catalog of all of our Lakehead Lives events on our YouTube playlist. If you have a question today for Dr. MacKinnon, I would encourage you to use the Q&A function on your Zoom, and we will answer all of those questions. So please do submit your questions. And stay connected with us on social media. Lakehead is very active on Instagram, Facebook, Twitter, and of course on YouTube. So we'll talk a little bit how you can find us near the end of the presentation. But now that we've gotten all of that out of the way, let's just jump right into it and talk about the chemistry program. So Dr. MacKinnon, perhaps you can talk about the different programs offered in the Department of Chemistry.
Sure. Do we have that? Do we have a slide for that, or this is the slide we're using?
It's just this is it. We're just gonna have a conversation.
Okay,
yeah, no problem.
Okay, so the sort of the standard in science, the Faculty of Sciences, so all of the programs, biology, chemistry, physics, geology, is the honors Bachelor of Science, and that would just be chemistry major and or biology major, physics major, whatever that is. So that's the typical program, and that program has, I would say, the most flexibility in terms of elective room. So you go through the program year by year. The way it's done is all of our programs will have a common first year, and then most of the second year courses would also be common, and that's to lay sort of the breadth, background, base information that everyone needs for having knowledge in all of the different subdisciplines of chemistry. So again, if you've taken high school chemistry, which I assume, again, if you're joining us today, you have,
I certainly hope so.
you know what the subdisciplines are. There's organic chemistry, there's physical chemistry, there's inorganic chemistry, there's analytical chemistry, there's polymer chemistry, there's biochemistry. So we have all of these courses, and we expect students to have a little bit of knowledge in all of those areas, and also in mathematics and physics, and then in other science as well, of your choice. So in first year, you have to take a science elective, and that could be something from geology, for example, or biology, or even anthropology. And then we'd also expect you in first year to take a, I guess it's called social sciences and humanities elective. And so that, again, is that could be anything. It could be psychology, like the first year psych course. It could be sociology or philosophy, or anything like that. So again, your first year, there's only the one chemistry course, one full chemistry course. So that means you take a semester in the fall, you take a course in the fall semester, a course in the winter semester, and those course numbers are chemistry 1110 or 1111. 1111 is the chemistry major, and I'll talk about the difference between those two courses in a minute. And then also in first year, you would take the physics course, you take the calculus course. Again, not just any math course, it has to be the calculus course. And then, like I mentioned, another first year science and another social sciences and humanities, which would be sort of your more open elective. So our two courses are very different in a sense this year because of social distancing and the primarily online delivery model that we're going to be using in the fall semester. We are planning to have chemistry 1111 be an actual lab course. So if you are in Thunder Bay, if you're available to come to campus, if you're willing to come to campus, and again, if you have any issues, if you're immune compromised, or if you have, if you're living with people who you think might be immune compromised, and there's no pressure on you to come to campus for the labs. But if you want to come to campus and take the labs in person, that would be available to you if you signed up for the chemistry 1111 course and the chemistry 1131 course. So we're going to run a full lab program in person on campus with glassware and actual chemicals for those two courses. And those two courses are limited to chemistry majors. So if you're in biology, as a biology major, chemistry includes chemistry and biology joint majors because that's a joint program. But if you're a straight biology or life sciences or physics major, you would be ineligible to take those two courses. And that's true every year. But this year, because of the severe limitations we have, to make sure people are spaced out in the labs, we're going to have a lot fewer people in those chemistry 1111 and 1131s. We don't have a lot of room to be able to get everybody through the lab every week.
Yeah, for sure. And
so,
I
but
know,
that is the.
I was just going to say, I know safety is one of the #1 priorities when it comes to this kind of stuff right now. So I'm sure a lot of our applicants can appreciate that.
Yeah. Yeah, and it's chemical safety as well as the COVID safety.
Right.
And that's also part of the problem, is that when you count the number of people in the room, you still have to have the instructors in the room, and that takes up a couple of spaces as well. So
can't have you still have to have the faculty and the graduate assistants available in the room to
that's right.
to keep everyone safety and to have instruction, right?
Yeah, that's right. So I'm not sure what biology and physics are doing with their first year labs. They may be doing something similar. So you could always contact them if you're a biology or a physics major.
For sure. Perhaps perhaps it might be worth talking about, because a lot of our international students today might not be able to come to Canada due to travel restrictions. That is obviously still up in the air. There's lots of time between now and September. Lots will change. Lots has changed in the last few months. But maybe it's worth talking about chemistry 1111 and 1131 from a distance perspective.
Okay. So and I've been in contact certainly with the upper year chemistry majors who I'm the academic advisor for, some from China, some from, I was just talking to someone from Mexico as well. So we're sorting things out for them. But for first year students, the alternative is to do chemistry 1110. And so 1110 is going to have a remote lab. Now, again, that means you won't be in the lab using the actual glass for yourself. But what we're going to do is have videos, interactive, hopefully, simulations, those kinds of things. And so you'll still get sort of the theoretical knowledge, and you'll certainly have to still write up the lab reports. You'll get data that's individualized for yourself. So everyone gets a chance to write up their own lab report, and we're working on making those videos and making those simulations and tutorials and things available. And again, that course can be used. So if you look in the calendar, I know some people will be worried about that. If you look in the calendar, it says if you're a chemistry major, you take chemistry 1110. Sorry, you take chemistry 1111 for the purposes of really any year, but certainly this year, chemistry 1110 can substitute for 1111 because they are actually the same class material, course material. It's just the lab that is different.
Okay.
And it's, again, especially true for this year. In a normal year, chemistry 1111 has 9 labs, and chemistry 1110 only has 5 labs. And so that ends up being sort of the difference, is you get a couple of extra lab experiments.
For sure. And for all of our students watching, chemistry 1111 and 1110 are offered in the fall semester, and 1131 is offered in the winter semester. And I think it's really worth noting at this point in time, I believe that no decisions have been made about winter semester, whether it's going to be a primarily online or in person. So I'm sure the faculty is making contingencies for the winter, but as of right now, we can only concretely speak about the distance model from the fall, and I think that's really important.
Yes, and we've actually already planned to have both models in the winter as well. So again, if campus is open, so now talking to international students again, if campus is open and everyone is normally expected to come to campus and have a normal, what we would call a normal semester, and you are from a country that you either can't leave the country, there's travel restrictions to get into Canada, we will figure something out for you. So we don't want you to lose the whole year. So we're already working on that. So don't let that be a barrier to coming to Lakehead or signing up for a chemistry program.
For sure. I would say that one of the great perks about being a school of Lakehead size is that we can really afford to work with our students a little bit more one-on-one in terms of helping them achieve success. And in this instance, achieving success might be working to facilitate distance learning. It's a big undertaking, but I'm really proud of how Lakehead's handled it to this point.
The good news is that for the person who's doing the instruction for 1130 already has the background practice, because of the last half of last year he had to adapt.
Right.
So yeah, so everything is half of it's already done. So
for
anyway.
Sure. So yeah, looking at the first year at a glance, we've talked about, I think we've covered most of this. Like you mentioned, first year students at Lakehead in the chemistry program, they do take 2 chemistry classes, 2 math classes, 2 physics classes, and then they will take a variety of elective courses. I just want to briefly talk about our master's programs, our graduate programs in chemistry. We don't really have a slide for that, but I know there might be some master students here about master's or even PhD level students. Dr. MacKinnon, could you maybe mention just briefly what's involved at the graduate level?
Okay, so we only have thesis-based programs, which means you have to have a supervisor, you have to do experiments, you have to create new knowledge, basically, and then do a proposal, presentation to the department, and then you would have to, and that's in your first year, and then then you would be doing your experiments, and then you would be doing a defense and writing a thesis. And so the defense is oral. So again, you'd stand in front of the department and you would give a presentation and have to explain, why you deserve to have your degree granted to you. It's typical. That's the typical master's program. You would take, I think it's 4 courses. So that's, in Lakehead parlance, that's 2 full course equivalents. But that would be 4 classes, say sort of 2 in the fall, 2 in the winter kind of breakdown. The PhD is also thesis-based, and you are expected to have a master's, or you would enter a master's program and then transfer into the PhD program after you'd have a successful first year. So in addition to your master's level courses, you would take 2 more courses. So if you already have an MSc degree and you came directly into the PhD, you'd only have to take 2 classes or 1 full course equivalent. And then there's a comprehensive exam, and that's very, very detailed. And so you have to, again, that would be a committee, an examining committee, and you would have to demonstrate that you have all the background knowledge you would need for performing your research and understanding it and defending it, and then write a thesis and have a thesis defense at the end. Right now we have our master's program, there's not that many students in it right now, maybe 6 or 7. And our PhD program has 20 some in it, 22, wow. 24, something like that. Now, one of the reasons for that is because a lot of people will enter the master's and then direct transfer into the PhD program. So they're only in the master's program for 1 year.
Oh, okay.
It depends on what you want to do. There are very good reasons to do a master's and stop at a master's, depending on what kind of job you want. There are other good reasons to do a PhD, but they're different, right? So you might want to talk to the graduate coordinator. If you're coming in, if you want to do a PhD and you already have a master's, that's different. But if you are starting, you're just sort of in your 3rd or 4th year of your undergraduate and you want to know what are the advantages, disadvantages, we do have a graduate coordinator who would be able to go over that in more detail.
For sure. A lot of that is just getting ready for what career you eventually want. And
That's
I
right.
think
Yeah.
that's one of the things, you know, I know all of our faculty really try and help our students with is help them plan for the career they want. That is the purpose of
Mhm.
university in the grand scheme of things, is to prepare you for a career that you're passionate about, and that's exciting. Um, Kind of circling back to the undergraduate courses, I know
Mhm.
that as we get into you know, first year is rather general, but as we get into second, third, and fourth year, there's opportunities for students to maybe focus their learning, even within the chemistry department, a fair bit. Could you talk about just kind of the maybe specializations or streams is maybe a good way to say it,
Yep.
of the undergraduate program?
Yeah, because I realize now that I started talking about the undergraduate, the HBSc in chemistry, and then didn't actually talk about anything else. I did mention biology and chemistry joint degree, I guess, as well. So that's
Yeah.
maybe the first place to start. So HBSc in chemistry is um, is one program. We have a joint program, biology and chemistry combined, and we have a specialization in medicinal chemistry is the name of this concentration, actually, not specialization. Those are actually two different things.
Yes.
Anyway, but the concentration is a larger chunk of courses, if I'm getting that right. Um, and uh, and then there are the education programs as well. So we have education, concurrent education in chemistry, concurrent education in chemistry and biology, and you can do teachables in either junior, primary, junior, or intermediate senior
Hmm.
in both of those degree programs.
Yeah, and
And
that those
so,
degree programs are really targeted to students who want to be a teacher, right? Like the
yeah,
purpose of their chemistry degree is, yeah, and their BEd degree is to get them into teaching. So we do offer
yeah,
that, but it's not. Yeah, there's lots of other options. Sorry, I didn't mean to interrupt.
yeah, no, that's fine. Yeah, so again, when people say education, it doesn't mean if you wanted to do higher education, like be a professor at a college or a university. That's not what education is for. Education is for K-12 or primary to grade 12 teaching.
Yeah.
Now, the good thing about if you do want to be a teacher or think you want to be a teacher, you can sign up for these concurrent education programs. And the good news is that you're taking education courses all through your career, and you're getting in the classroom early. And so I don't want to, I don't want to discourage anybody, but it is a different thing to be in the classroom on the teacher side than it is to be in the classroom on the student side. And some people decide, it's better to find out in your first or second year when all you've done is lose a course or two, and you can use those courses as electives in your science degree. Um, it's really good to be out in the classroom right away, and you get to know, oh yeah, this really is what I want to do, or this is not what I thought it was going to be, and it's not for me. So we've had, of course, students that have been in both camps, right? Usually people that are in education, they are in there because they want to be a teacher, and they stick with that all the way through, and they enjoy it, and they get jobs and everything, and they're happy about that. There's always one or two every couple of years who like, yeah, you know what, education is not for me after all.
Yeah, I think what happens, you know, I've talked to students who have done that, is they find out what they were really passionate about is their major. So in this
Mhm.
example, you know, they had a great high school chemistry teacher. They thought maybe they'd like to be a teacher, and they get into their degree program of chemistry and education, and then they, like you said, many go through and finish the dual degree, but some find out that they're really most passionate about chemistry, and they start to pursue other careers in their major. And this happens, of course, in all different other majors, but I think it's an interesting phenomenon.
Yeah, yeah. Okay, so kind of circling back then to the non-education programs. So we have the chemistry biology joint major. As you can imagine, it is a very full major, because you end up with a full chemistry degree and a full biology degree. and you do that in 4 years. So a lot of places will have joint majors, but you end up having to add in years. We've actually built it so that you can complete it in 4 years. Does mean that you have maybe one elective after your first year. But if you do like chemistry and biology, then this is a great opportunity to be able to do both. And we have lots of professors and instructors and courses that are at the interface between the two. So, biochemistry courses, molecular biology type courses. We have things like cancer biology. And even though the word biology is right in the title, cancer biology is really, cancer is generally speaking a molecular disease, right? It's an error in your DNA oftentimes. And so you really need that chemical background to be able to understand the biology of cancer. And so, there's all kinds of courses like that. We have medical imaging courses. We have biophysics courses as well. And so that would be things like doing MRI, doing CT, doing high frequency ultrasound, things like that. So lots of opportunities there. And then that sort of segues into our specialization. So if you're not interested in biology per se, but you are interested in, say, medical sciences, we have this medicinal chemistry concentration. And what is medicinal chemistry? That can be a lot of things. Maybe the most obvious are things like drug design. We have a course in that. We have a course in cyclotron, radiopharmaceuticals. So that's using radioactive elements as diagnostic tools. And so we have, for those of you that aren't from Thunder Bay, there is a cyclotron. And so that's like a particle accelerator, and you can make radioactive elements in it. So for example, one of the elements you can make is fluorine, the 18 isotope, which is radioactive. It decays by emitting a positron, which is important because positron emission tomography is a type of imaging that you can do at the hospital or whatever that requires this positron emitting isotope. And it's really useful for diagnosing a lot of cancers, especially cancers that are metastasizing. You can find cancer at very, very early stages using this technique, much earlier than you could just using a normal MRI. Medical imaging can also include things like, medicinal chemistry can include things like contrast agents for MRI. So we have one professor who's working on imaging the lungs. So MRI usually works by imaging the water in your body, how much water it is in various locations. Your lungs don't have a lot of water in them because they're full of oxygen and nitrogen and carbon dioxide. And so he's working on ways that you can image the lungs by inhaling, a gas that might show up on the MRI instead of water, right? So you retune the MRI to pick up xenon instead. So xenon is one way they do it. Or to pick up fluorine instead, and you inhale a sulfur hexafluoride gas, which sounds really nasty, but actually is completely inert. And so anyway, he's doing a lot of research on those, on that kind of thing. So we have 3 research chairs in medicinal chemistry who are jointly appointed with the Thunder Bay Regional Health Research Institute, which is a research institute run by the hospital. There is also the, what do they call it? The Western campus of the Northern Ontario School of Medicine.
Yeah.
And we have people in that who are faculty members at NOSM, who are adjunct members of chemistry and will supervise, say, honor students. Sometimes they'll teach courses. And so you can do medical research in your 4th year. And so all of these programs I've discussed, and Patrick mentioned it before about experiential learning, all of them have the option to do a 4th year research project. You also have the option to possibly do a 3rd year internship, which is again a research internship. And when we say research, we mean it's actual research, right? You're going in the lab, you don't know what you're doing, but you hope that if you do this, you'll discover something new, or you'll make something new, or you'll learn something new. And it's an exciting, it's interesting because it is something that's never been done before. So myself, I'm a synthetic chemist, and my students, all of them, are given a project that is, at the end of it, they will have a vial or 3 vials or 10 vials with material in it that no one has ever made before in the history of the universe. Well, history of the known universe, let's say. And that's always very satisfying. I made this, and this is the entire world supply is in this vial because I'm the only person that's ever made this.
That's actually really fascinating. I didn't know that. That's really cool.
Yeah. So when we say research projects, that's actual research projects and publications. I have students, undergraduate students, people who work for me for an honors project, have publications in the primary literature that's been, peer reviewed and is now out there for everyone to see. So
I think that's
so maybe
that's a really good point, is that students in our chemistry department are getting the opportunity to actually, as an undergraduate student, get peer-reviewed, published information out there. And I think that, like, when you compare that experience to potentially other experiences that you can have in other chemistry programs, that's a really amazing opportunity for our undergraduate students.
Yeah, and it's the only time we would turn a student away is if their average isn't high enough.
Sure.
You do need a 70 average, but otherwise, if you want to do a project, it's pretty much you can do a project. Some programs require a project. Actually, the HBSC in chemistry, we require a project. The biology chemistry joint degree, it's optional, and you can do it either in biology or in chemistry, or you can find someone at the interface and do it in, say, biochemistry or whatever. If you're in the medicinal sciences, medicinal chemistry concentration, then you would do a medicinal chemistry project. Now, I've sort of emphasized the medicinal stuff. I don't mean to suggest that we only have that. I'm an inorganic chemist. I'm working on metal organic frameworks. I do things like, so metal organic frameworks are, you have a metal, you have an organic piece, and you join it together and you make a 3-dimensional structure. And if you do it right, you've got spaces in there, and then you use the spaces for something. So you might use them for sensors. So metal organic frameworks are being used as sensors for nerve gases, for example. So you'd have a patch or something with this metal organic framework printed on it. You go to in the field, it turns color, you've been exposed to sarin or VX or some kind of nerve agent. There's sensor applications for other things like mercury, for example. If you wanted to test well water, arsenic, things like that, you can use them as storage. Sort of I'm looking for. Well, hydrogen storage, if you're thinking about things like the hydrogen economy, using hydrogen for fuel, it's much safer to have hydrogen stored within a matrix than to just have a tank on the back of your car that's full of compressed hydrogen. You're in a car accident, the tank breaks.
Super flammable
it could be
substance.
Spectacular.
Yeah.
It's like you'd be a mini Hindenburg.
That would be no good.
Yeah. So those are the kinds of things that I'm looking at, and that the people in my field are looking at. We have one professor who's looking at, he does some concrete research as part of his research, how to make concrete. And that may sound more industrial, but it's very relevant. Concrete accounts for something like 10 or 12 or 15 or whatever it is % of CO2 emissions in the world. So if you can do anything to and people pour concrete everywhere all the time, right? Yeah, so if there's any way you can make concrete stronger with it by reducing the amount of cement that generates CO2, then that helps the environment. So there's an environmental angle there, there's an industrial angle there. And there's a basic chemistry angle there, understanding how the matrix in cement works. We have people who are doing, what else have we got? We've got computational people, again, on both sides of the spectrum, sort of the very theoretical computational people who look at really small molecules in really great detail. What is aromaticity? So you've heard that term before, I'm sure, aromaticity like benzene, but how do you define what that aromaticity means? Everyone kind of knows what aromaticity is, but how do you actually define it mathematically, physically? And so he's working on things like that. We also have a computational chemist who's doing docking. It's one of the things she does, bioinformatics. And so what she is doing is, here's a protein, a known protein, right? And so you build a model of the protein in your computer, then you see what chemicals interact with it and where, and what would that do? So for example, if you have one of the projects she's working on is peanut allergies.
Okay.
How to block that histamine receptor so that if someone is suffering anaphylactic shock, can you give them a drug that will block that receptor and therefore stop that feedback loop that causes the anaphylactic shock? So, and there are drugs, of course, out there that do that, but
I think it just highlights the wide variety of uses and research areas and industries that a student with a chemistry background, a chemistry degree, can get into. And we're going to talk a little bit about career opportunities in a minute. We do have two questions, one for me and one for you, Dr. MacKinnon. So the first question is how do we register if we're going to study online? Course registration is the same as it's always been. You register for your classes on Lakehead's website through the MyInfo portal. And Sylvia, our Lakehead expert behind the scenes here, is going to link the FastPass webinars, which help students register for classes. But the registration process hasn't changed particularly. The question for you, Dr. MacKinnon, is how often do you offer Chemistry 2610? And for this year, they're assuming that 2610 will be offered entirely through online model. And so I looked up what Chemistry 2610 is, and on the course calendar, that is the Northern Environmental Chemistry class.
Yeah. That is offered every year. It's offered every year at both campuses. So this year it happens, am I going to get this right? It's being offered on the Thunder Bay campus in the fall. So as you know, that will be completely online. And Dr. Oba is experienced instructor. He's taught it several times. So I think it's a good course. And then Dr. Laredo also has taught it many times at the Aurelia campus. We'll be offering it in the winter.
Okay.
Now, I think if you are, depending on what campus you're on, because it's going to be all online, at least in the fall, if you are in the Aurelia campus and you want to take it and it only fits in the fall semester, maybe I shouldn't be offering this, but I think theoretically, Aurelia campus students can take it on Thunder Bay by distance ed. I don't see why there's any reason why.
Right. What's the difference between being in Aurelia or being in Dubai, let's say, in the United Arab Emirates in that situation? Online is online.
And certainly we're doing that with other courses. So I assume 2610 would be allowed. That would be allowed. I don't necessarily control that, but
yeah, that is maybe one of the silver linings of the all online fall semester. I do want to just pivot quickly and talk a little bit about some of the career opportunities a student can have. I think you've really highlighted a variety of the fields that chemistry students get into. And then these are some of the more concrete careers. Obviously, we've talked a lot about the medical sciences, and so chemistry students go on to potentially degrees in the pharmacy field, the pharmacology field, but there's a whole bunch of these. I don't mean to put you on the spot, but is there some really interesting jobs that some of our graduates are doing in terms of graduating with a chemistry degree?
Mhm.
I know some of these
Yeah.
are yeah.
So, I mean, the most obvious thing, I always do like to talk about medical school because I know a lot of students are
Sure.
interested in
Yeah,
that.
that's very popular.
Medical school in Canada has very few prerequisites now. So you can have a degree in X, it doesn't matter what, theoretically in music, in English,
Yes.
in physics, in mathematics. So I know, I do know absolutely for sure that a HBSC mathematics major is currently doing medical school at the University of Ottawa.
Okay.
His name's Tim. I'm not going to say what his last name is. I don't know.
For
But
sure.
anyway, so Tim got, I think he might be in his last year now, or maybe his third year. Anyways, and he's doing very well. The only advantage to having a degree in, say, chemistry or biology or something like that would be in writing your MCAT. So there is a biochemistry section, there's an organic chemistry section on the MCATs. And if you're taking those courses, you might find that part a little bit easier if the med school even requires an MCAT, which not all of them do. So if you are thinking about going to med school, do what you are good at, do what you are interested in, because you are going to do much better and you're going to have a much more enjoyable time in your undergraduate and probably get better marks if you're doing what you like. Now, having said that, a lot of chemistry majors go into go into med school. A lot of them go on to pharmacy, so that's the first one there. And pharmacist doesn't mean just necessarily working in Walmart pharmacy. It could mean that. Pharmacists get paid very well, even at Walmart. I do have a couple of students who did sort of extras when they were going through. Student who worked for me, Shauna, she did compounding pharmacy course in addition to her normal pharmacy course. And so she can make drugs, just pull chemicals off the shelf and make them in a different form, for example. So if you have problems swallowing a pill, you'd have to go to someone like her, and she might make it into a suppository or an injection or some other form, or make it fast dissolving so you can just stick it under your tongue, or those
Wow.
kinds of things. So I noticed that dentistry is not there. I just saw an ad in the newspaper. Yes, I still actually get a physical newspaper about dentist office reopening, and one of them is one of our graduates who did an HBSc in chemistry and then went on to dentistry, and she is now not dentist or not orthodontist. There's another periodontist.
Yeah, that is a thing. Yeah.
That's what she is. I have a friend who I went to school with, who under cosmetics formulation there, who works for MAC Cosmetics.
Okay.
And so she's a formulation chemist there. So she, cosmetics is moving away a little bit from animal testing, actually moving away a lot from things like animal testing.
Yeah.
And so now if you want to create a new formulation, you've got this, you want a different color, you want it to stick better or be more waterproof or whatever. You've got a limited number of things you can work with, but by combining different things, you can make products that are better. And so basically that's what she's doing, is she has, the list of chemicals that are allowed. And again, everything is a chemical, right? Everything that you're working with in these, everything is a chemical, right?
At the base level, everything is chemistry.
At the base level, everything is a chemical.
Yeah.
So that's what she does, and she enjoys that. And what else have we got here? Yeah, I mean, things like water purification, toxicology, there are, those are, of course, if you're into, being into environmental science or interested in the environment, things like that, almost all environmental issues have a chemical, somewhere in the chain, there's a chemical, reason or an understanding of chemistry will be necessary for helping do that. We've had students go on to become, was it oenologists? Wine experts, anyway. So people who are, again, a fellow I went to graduate school with, good poker player. Maybe I shouldn't bring up the poker here, but anyway, he is a vintner, I think. So he runs his own winery.
Okay.
Another student who graduated from Lakehead actually owns a microbrewery for making beer, craft beer. Another graduate from Lakehead is a cork person, so like synthetic corks and things like that. He was one of the first people to start designing those things, and yeah, he's got a lot of money now.
Yeah, well, I was gonna say that's
One of those
incredible.
entrepreneurial things, like,
yeah,
oh, what can we make fake cork? It's like back then it was like, oh, synthetic cork, that's not real.
That's not viable. That's not a real.
That's not viable. Yeah.
Yeah.
But, he worked it out, and yeah, so he's doing very well for himself.
No kidding.
Patent agents, again, a couple of friends of mine who I went to school with work in Ottawa at the patent office, and yeah, that covers.
That's a huge range of careers. That's you've covered a chemistry degree can take you pretty much anywhere from a medical degree to working in like the culinary sector, it seems, to working in research and innovation and entrepreneurship and everywhere in between. It's a
and
fascinating.
Actually, if I can add just one
Sure.
more, a guy who did his BSc and a master's with us, he eventually ended up at PPG. Which is Pittsburgh Paint Group or something like that. And they make coating paint for cars. And so his job was to make that process more environmentally friendly and hopefully at the same time cheaper. And that's not a trivial task, as you might imagine. If you're painting a car, it has to last. There has to be the undercoat, it has to stick to both metal, or the primer at least. You have to be able to put that diamond coat on the top of it. You have to have it be the same color if you're putting it on plastic or on like aluminum or metal, or new cars, especially if you're talking about high performance cars. They're now made of composite materials like carbon fiber and things like that. You have to be able to paint all of that stuff and have it all look the same color in the end, right? Because people don't want their it has to fade and interact with the light the same way, and it's actually quite a complex system. And so you don't think of paints as being something that's an environmentally important or environmentally friendly or whatever, but paint actually is really important.
Huge.
You paint your house to make sure it lasts longer.
Yeah. So. Yeah. I just want to, some feedback we've gotten in the Q&A. Pierre said this was a very enlightening session. He learned a lot about chemistry, and he just wanted to say thank you. So I just want to thank Pierre for tuning in today. We're getting close to our hour mark, so I just want to put out one last call for questions. If you have questions for Dr. MacKinnon or I, and there is one about study permits that I'm happy to answer. The question is can we start online classes if we do not have our study permit yet because the biometrics aren't possible? So I'm going to say the answer to this question is yes, you can start online without your study permit as an international student. However, I would encourage all of our international students watching today to start their study permit process because you can start the process online, and if classes resume in person in winter, we don't want you in a position where you're not able to join us. So please do start your study permit process, but the answer is yes, you can start your courses online if you haven't been able to give your biometrics yet, and just get it to the point where you are able to get your biometrics. All right, and so I'm just gonna start my wrap-up process here, and as we wrap up, if there are any other questions, I'll check in just a moment. As I said earlier, follow us online. Lakehead University is on all social medias. We have our Facebook page at Lakehead University International. We are on Instagram at Lakehead International. We have our Twitter at Lakehead INTL. All of our webinars go on our international playlist at Lakehead University. And I'd encourage all of our incoming students to take a virtual campus tour. You can do that at lakeheadu.ca tours. It's easy. You can do it with any device, a phone, a tablet, a computer. You can, as Jordan would say, you can do it from the comfort of your couch. And it's a great way to experience what our campuses are like, what student life is like, and see where you will be studying. I'm just going to check one
And if
more
I
time.
can just, while you're on that
Yeah.
picture, you can actually see, I don't know, no, I can't point at it, but you can see my lab in this picture. My lab
really?
is right at the corner there. There's like 3 people walking by, and yeah, my lab is on the 2nd floor right there. My research.
That's interesting. I moved the slides. So I just want to thank, it doesn't look like we have any more questions. I do want to thank Dr. MacKinnon for joining us today. I know all of our faculty are busy preparing for our fall semester. There's lots to do before we start the semester, so I appreciate him taking some time out of his busy week to join us on this Faculty Friday. And thank all of you for tuning in. As I said earlier, our Monday meetup will be back next week talking about graduate students, and we're live every day at 10 a.m. Eastern Daylight Time, which is our time zone here in Thunder Bay and Orillia. So thank you again for joining us, and we will see you next time.